All right, when we left off, I have up on the screen left you with this part and asked you to proceed to make a part program that incorporates rapid movements and feed rate movements where appropriate to position and do cutting on this particular part. I hope you found it not too terribly difficult to kind of jump ahead, and even though I haven't talked about circle interpolation for full circles, logically you can do it the same way we did, and we'll review that in just a few moments as well. So right now, if you look at this part, first thing you see is that now we're getting to be a little more like you'll find out in the actual production environment. Datum corners aren't really randomly selected places on a part. They're usually logical places, such as the lower left-hand corner, lower right-hand corner, some part identifiable feature that can be indicated and dialed in as terms of where that part is sitting. Now, what we have is to consider an engineering drawing. As we looked at that, you'll see that dimensions on engineering drawings typically all come from a common point on a particular part. That's generally where we assign the datums, from a common point on the part based on the engineering drawing that the dimensions kind of stem from. They'll have reference surfaces and such. So this part just so happens that we have the lower left-hand corner sitting right over our grid point datum. And I have taken the part and drawn it up on our board here. Here's our datum, so point number 1, point 2, point 3, and so on, all the way around the part have been identified. And now what you want to do is look at the x and y axes values that I have up here. And you'll see that the first point is at x0, y0, and the next point is at x0, y8.0, and so on. So we've identified all the x and y coordinates of all the relevant points. I've also taken these circles and identified an x location for the center point and an x location for the point out on the periphery. So we got two more points here. The black hole has a point at the center at x3 and a point out on the periphery where the center line crosses the feature at y4. So now, given this, we have enough information to create a pretty nice part program. So based on what we've talked about so far, I imagine that you would want to make our first move to be a rapid move to x0, y0. So we'll go g00 here, and there's our first move. And then we'll include the g90s and the g20 as well. Remembering that g90 says all these coordinates are based on a common datum point. g20 says all these values are inches. So now we're sitting right here and we want to move up to point number 2. We can imagine that a cutter is actually in material here. And so we want to move at a feed rate and climb mill our way up around the profile of the part. So if you remember, a linear move is g01. And we need to add one more word, and that's what? You know, our feed rate. Our feed rate, and I'll just pick a number of 5 inches per minute. And now we have established a move up to point number 2. So the cutter is now sitting here. And then over to point number 3, remember we don't need to repeat the G01 or the F. The control will remember what was active. So now we're just having an x4 and y8 move, so that moves across to here. So now we're sitting there. And now we're going up to point number 4, which is moving still at G01, we're moving to x4.0 and y12.0. So now the cutter is sitting here. So we know that the next move to get us to point number 5 has to be a circular move, right? And is this a clockwise or counterclockwise? Well, it's a clockwise arc. So what we're going to do is we are going to say, right now we're sitting at point number 4, okay? We're sitting here, but we want to get to point number 5. So the movement to get us to point number 5 has to be a clockwise arc. So there we have, and say, G02. And then we provide the x and y coordinates of the end of that segment move. Each of these we'll call a segment if you want. Now, we still need some information that defines this arc a little bit better. And remember the I and j value? And do you remember how we figured that out? The way we figured it out was we said, okay, if we consider where we're currently sitting, and we pretend that that point is in actuality the datum point temporarily. We make this and think of this as a temporary datum point. Where, if I were to say from this datum point, where does the center of this radius lie in relation to our temporary datum point? The answer would be, if you notice, this arc has a 1-inch radius to it. So the center point of the arc is 1 inch over. And I know that because we have the arc ending at a straight line here. It's moving up 1 inch and over 1 inch, so that means it's a 90-degree arc. So the center point would be right here at x 1.0, and it's at y0. Are you with me there? But if you remember, we do not say x and y when we're in the GO2 command, because the x and y represents where we want to end up. So we then use the I instead of saying x, so my I, or the center point, is at 1 inch in the positive direction, and it's at J0. And now we have a complete and correct GO2 block with the cutter now sitting right here. Now what do I need to say to make a straight line move to get to point number 6? Well, I need to provide the x and y coordinates. You remember? We have to cancel out this circular move, so we would now say G01 again to put it back into linear interpolation. So now it's sitting here. Now our next move goes to point number 7, and we're sitting at point number 7. We're sitting here. Now you see we have another circular arc that we want to end up with the cutter on point number 8. Now the center of the radius is sitting here, and the circle is a 2-inch radius. How do I know that's a 2-inch radius? If I look at my drawing, I see that it ends up right here. It begins there, so it's 2 over and 2 up. So it's a 2-inch radius, and its point is at x plus 2 from our temporary location, right? So if the cutter's sitting here, we're 2 inches over in the x plus direction, and we're at the y0 direction. So is this a clockwise or counterclockwise move? It's counterclockwise. So I say G03. And now we're moving around the arc, and our x is our x value for the arc relative location. We substitute and say I, and then it's 2 inches over, and it's at J0. So now we have another proper arc command. Cutter's sitting here. We want to go back into a straight line move, so now we say G01 again, x10, y7. Notice I haven't repeated the feed rate. The feed rate will apply for all of these blocks. So I don't even need to repeat the feed rate. All we need to do is reestablish whether we're linear or circular, counterclockwise or clockwise. We always have to reestablish that with a proper G right in the file. So now what we're doing is sitting at point number 8. I'm sorry, I put the G03 in the wrong place, so let's make a quick correction here. My intent was not to confuse. I hope you caught that. That would be good. Point 7 is where we started our arc. So the G01 command brought us down to point 7 with this. So that, nothing needs to be said here. Getting to point 8 is where we need to put the G03. And then the I has to be 2.0 here. And then the Y, or J, needs to be 0. So now we're sitting at point number 8, and we want to get to point number 9, and here is where we need to reestablish our G01. Then down to point number 10 is at x16, y0, and then going back to x0, y0. Now, to do a full circular interpolation move, it's really easy. And if you have noticed and read the manual that we have up on the screen, it talks about right here, cutting full circular arcs. It's really kind of easy when you do it if you realize where the center is and where you want to start cutting. So the movement to get into this arc, for example, what we probably do is we're now sitting right here. We'll say G00 and put ourselves right at the center of the arc on point number 19. And now we'll make a straight line move over to point number 20. And that would be a G01. So now we're sitting at point number 20. If this were a quarter circle like we did here, what would you need to say? All we would need to say is the direction and then where the I is, but we'd have to provide the coordinates to where we're going. Well, because we're beginning and ending when we're cutting a full circle at the same location, all we need to say at this point is G0, and now we're going to go clockwise or counterclockwise, whichever one, doesn't matter. Well, it does matter depending on the finish you want, but let's just say we're going counterclockwise, so we'll say G03, and all we're going to do is go back to the same location where we're currently sitting at, X13.0, Y4.0. Now we provide the I, just like we always have. If this is our temporary datum point, where is the I in relation to our temporary datum point? I minus, this is a 2-inch radius circle, so it's minus 2.0 J0. So then it goes and makes a very nice full circle cut. And now you probably want to say G00 over to point number 30. Always remember to reestablish your position. And then we do a G01 to point number 31. So now our cutter is sitting right here, and we want to do another full circle. So all we do is go and repeat the same location we're at. So we just simply say G03, X 4.0, Y 4.0. Where's the I? This is our temporary location. Where's the center of the arc? It's right here. Minus 1, it's a 1-inch radius. And we're at J0. And then we probably want to make another last rapid move that says G00 and go back to X0 and Y0. Take us back to there. And now we have the makings of a part program for our sample part that we left off with. So now, what we've done is I've taken and now made this part, like simplified it. We're going to take off our training wheels now, if you so to speak. We're not going to draw the axes on here anymore. We're now going to imply that if it's something going across, this is our x-axis. If it's something going up and down, it's our y-axis. So we know that this part that we just completed is sitting at the x and y origin right here at the lower left-hand corner of the part. What this program does not have, this will produce valid movement in x and y only. We do not have a z-axis in this part. So in other words, can you imagine what would be happening if we started this part program and we went and actually had a cutter down in material, cutting this part, and then we get over to this point right here where we want to jump to this circle? We make a rapid move. Mind you, the cutter is still in the material and it's going to rapid travel right through the thickness of our part. So obviously that's not what we want. So we have to consider putting a z-axis down to a cutting depth, cutting a profile, picking that z-axis up, moving it to another location, dropping it down, machining a part, bringing the z-axis back up again, moving it over, bringing it down, and so on. So our x and y axis movements are all correct. There's nothing wrong with them. But what we would do is, for example, now, what we need to do is we need to position a g0, 0, x0, y0, and then we need to move a z-axis into position. And the way we do that is we simply see that just like we have the datum point for x and y, if you remember from way back when we started this discussion, that this is actually a three-dimensional coordinate system with a z-axis. So there's a z-axis datum point that we can consider now. And that datum point we generally set at the top surface of the part. And we did that, if you noticed, when we were doing our setup on the floor. We went and just kind of indicated the vise, but we were, indicating in x and y, but the z-axis could move up and down. And the z-axis now, we pick the top part surface and then say, okay, if this is a part that is 2.5 inches thick, what we're going to do is we're going to move the cutter into position, and then we're going to tell it to move the cutter down, because remember, our cutter is a cylindrical object that will end mill as we move around, that we want to move the end of the cutter 2.5 inches down from the z origin, and then we'll finish this cut, and then we want to move it up, over, and down. So what we'll do is we'll rewrite this program and we'll add the z steps as we get to it. So we start our program off with G90, G20, and then we say, hey, G00, X0, Y0. So now, wherever the machine happened to be, it now makes a move to the origin. So it would be a good thing to bring the z down to depth right about now, at this time. So we did a G00, so what we probably want to do is move the z down at a feed rate. So I'm going to say G01, z minus, and as I said, we're going to assume this part is 2.5 inches thick. So we want to take the bottom of the tool and make sure it's at the bottom edge of the part, z minus 2.5, and we'll do a feed rate right here of 5.0. So now to simulate movement, well, all we're doing is saying, okay, G00, X0, Y0, we assume the machine is at its z plus position, and now we're saying, okay, move the z down to minus 2.5 inches. And now the z is at the proper depth, so we can do this entire profile without having to take the z up anymore. We want to leave it down and cut all around the profile. So now we simply say, X0, Y 8.0. So now it goes from here to here. And now we say x 4.0, y 8.0. And now we've moved from here to here. And now we go up to x 4.0, y 12.0, and that puts us here. And now we do our G02, x 5.0, y 13.0, I 0, j, or I 1.0, j 0. So now we're sitting here. And now we do a G01 to x 8.0, y 13.0, and then we go to x 8.0, still in G01, y 9.0. So now we're sitting right here, and now we do our G03, x 10.0, y 7.0, I 2.0, j 0, and now we're sitting right here. So now we do a G01, back to x 16.0, y 7.0. Now we're here, and now we do G01, x 16.0, y 0. All right, so now we're here. I don't need to repeat this G01, so we could just say x, in this block, we could just say x 16.0, y 0, so we are now sitting here. Now we go back to x 0, y 0. So now we're back to where we began. Now would probably be a good time to lift the cutter up out of the part before we wrap it to the center of that circle. So now I'm going to go and say G00, and I'm going to pick a spot that's about 5 inches above the axis origin. And we simply say G00, Z 5.0. So now the machine moves up, and now we do our positioning to the point number 19. So I'm going to say here G00, X11, Y4. So now we're sitting up here in space, 5 inches or apart. Now we probably want to bring the cutter down into the material if it's a center cutting end mill. We'll assume that it is, so now we'll say G01, Z minus 2.5. And now it's going to go at a feed rate and bring the cutter down through the material. So we're sort of sitting right here now, ready to do this circular interpolation. So now I'm going to say G01, we're sitting right here now, G01. Since I already set G01 on the Z move, I don't need to repeat it. So I can simply go to X13 now, Y 4.0. And now we're ready to do our circle. So now is a good time to say G03, restate X13.0, Y 4.0, I minus 2.0, J 0. So now we go and we do a full circle here. And if you want to, you can pull the Z up right from this position. Some people would prefer to bring it back to the center, in which case we would just say G01, but we'll just lift the Z up slowly. We'll say G01, Z 5.0. And now we're sitting up in the air, and we want to wrap it over to the other hole. So now we're going to go and say G00. Position over X 3.0, Y 4.0. Now we're going to bring our tool back down at a feed rate to the right cutting depth. G01, Z minus 2.5. And now we say X 3.0. Y 4.0. And now we just say G03. I'm sorry, we're going to over to X 4.0. Because we're positioning right here. 3.0 in X is this center point. 4.0 is that point. So here we are at X 4.0, Y 4.0. And now we do our G03, bring it back, X 4.0, Y 4.0, I minus 1.0, J0. And then we can say, once we're done with the arc, we simply say G01, Z 5.0. And remember the other command that I told you to put at the end line of every program? M30. That tells us that the program is finished. Now, we generally wouldn't leave the cutter sitting over the part, even though it's up in the air and end the program. We would probably move it over and out of the way before we end the program. So let's do that as one last rapid move. So I can now say G00. Let's go to X minus 5 inches, Y plus 10 inches, and then do the M30. So what that does is it has the cutter sitting here up in the air. It's going to move over to this location and then end the program. And now we have the makings of a proper NC program, almost. There's still things missing, but you see we're increasing the accuracy of our program, that it's going to be doing real stuff as we go here. So now I want to talk a little more about the modals. Take a look at this block here that we did. We're going to X0, Y 8.0. Before that, we went to G00, X0, Y0. Now, what's the same here? The X0, and then the X0 is actually repeated again. Here, the Y 8.0 is repeated. We don't need to repeat those numbers. Those are modal as well. So, to simplify this program and make typing a little easier, and I'll just do the first couple lines, we would make it to say G90, G20. Now we're going to do our G01, or G00 rather, to X0, Y0. And then we're going to do our G01 to Z minus 2.5, feed rate of 5.0. And now our next line is going to say X0, Y 8.0. So I don't need to restate the X0 if it's the same as it was in the previous block. So X0 is there. So now all I need to do is say Y 8.0. What that does is it'll make a rapid position, get us over the part. It will bring Z down. It knows it's sitting at X0 right now. So therefore, I don't need to repeat the word X0. I can just say Y 8.0. And now look, this next block, we're already at Y 8.0, so I don't need to repeat that. I just will now say X 4.0. And now it's going to make just an x-axis move to there. And now we're going to go up to this point, which is simply a y-axis move, Y 12.0. Now we're sitting right here, and then we insert the G02 the same way. We say G02, that has to have both of them because they're going to be different, right? So X 5.0, Y 13.0, I plus 1.0, J0. And so on. So we're eliminating more typing, and now we're starting to resemble what you'll commonly find out on the floor, a streamlined program that still moves to the same axes but does not repeat redundant information, has a beginning, has an end, and has Z moves so that you're not cutting through your material. So with a one tool part program, this is it. It's done. We're finished. You can transfer these blocks over into the reduced program, but for the parts that we've done here, you have a valid program. It's complete, it's self-contained, and it's ready to go. The only thing we didn't do in this program, if you remember, when we do machining, the spindle has to be turning, right? We can't have a stationary tool and expect it to do profiling around our part. So one of the other things we need to do, we need to turn on a spindle to the appropriate RPM. And what is the appropriate RPM? Well, think back to our speed and feed discussion in machining processes. And you would need to know what material type this is. So if this were cold rolled steel, 1018 for example, you would have a spindle speed maybe 800, depending on your cutter diameter and so on. But point is that you want to turn on the spindle. And now I'm going to introduce you to the spindle on code, which you're going to want to do before you start putting the cutter into material. So at this point in the program, just above our positioning move to X0 and Y0, we will insert a command. So here we have our G90, we have our G20. We will insert the letter S for spindle. Now some RPM value. So if we want 850 RPM, we say S, 850 RPM, or just the number 850, and then the letter M, and then the number 3. So here's two new addresses, S and M. Well, we talked about the M30. Anything that begins with the letter M is called a miscellaneous function. It does various things on the machine. For example, an M3 says turn the spindle on in a clockwise direction. M4, on the other hand, says turn the spindle on in a counterclockwise direction. And what we're going to want when we're all done machining, just before our M30, we're probably going to insert a code that says M05, which means turn the spindle off. So now, with these corrections, we basically have plenty of program code to produce this part if we wanted to. Of course, in our examples here, we don't consider work holding. You know, is this in a vise? Is it clamped? Is it on a magnetic chuck, a vacuum chuck? We're kind of avoiding talking about work holding at this point, even though we introduced it to you before, just to make the programming, learning the programming, a little simpler. That's why I started you off just talking about X and Y movement. And then we added the Z movement. And then we're adding codes as we go. So we're assembling a proper program in smaller chunks, in smaller pieces, just to make it a little easier to grasp rather than throwing all of this work holding and spindle speeds and feed rates, all of this up front. Because I want you to really have a good handle on simply making the machine move properly. Rapid, linear, circular, and then worry about the miscellaneous stuff that we need to insert to make it a program for actually cutting some material. So at this point, what we'll do is assign you a new drawing, and that would be on page number 30 of your handbook. Here is a part. Unfortunately, we have an arbitrary sort of datum point there, but that's all right, you can still work with it. So please make a proper program of this part with the addition of the z-axis moves as we have demonstrated here with this program. So go at it the easy way. First get all your X and Y locations, and then start formatting it with G01s, G00s, then add your Z values. You've got a full 180 degree circle here, 180 circle there. We have a full diameter circle right here. And now what we have is actually a problem with where the center is. These centers are right here on these grid marks. So go ahead and complete this part. Our NC program with all the rapid approaches, feed rates, Z movements. Notice though that this circle, it's not real obvious where the center is, but the center, if you look at, it's at -3.5, so it's halfway between the 3 and the 4 inch mark. And then it's halfway between the 0 and 1 inch. So its X value is -3.5, and its Y value of the center is at -0.5 inch. So that's not real clear and obvious, but these slots here, yes, we have the center points clearly discernible there. So please make this your project with a complete program. Include spindle speeds, Z moves, rapid motions, and so on.